Here is our motorboat problem, that we're calling it. So we'll read it first. A motorboat can go 10 miles downstream on a river in 20 minutes. It takes 30 minutes for this boat to go back upstream the same 10 miles. Find the speed of the boat. So the one thing we need to know about currents is that if I'm going downstream, right, I'm going down a river, what's happening when I'm going downstream? The current is working in my favor, correct? When I'm going upstream, I am working against the current. Think of riding down a hill or riding up a hill on your bike. Same ideas in effect, okay? So I have two things that influence the speed of my boat. I have the actual boat speed, and I have the current. So we're going to call those our variables. So I'm going to call, I don't like to use S's for speed because I make them look like 5, so I'm going to call M my motorboat speed. And then I'll call C the current. We'll just call it current speed. I'm sure there's a better word for it, but that makes sense to us. So I'm going 10 miles total, right? When I go the same distance, so I can set these equations up the same, it takes me 20 minutes when I'm going downstream. So when I'm going downstream, the current is helping me go along, right? So it's helping my speed go faster. When I'm going upstream, it's working against me. So that current speed and I are being added together. So I'm going to first of all find out what that speed is. So let's see if I can go 10 miles in 20 minutes. So if I can go 10 miles in 20 minutes, how many miles can I go in 60 minutes? Well, that's a simple proportion, right? This is times by 3. So that means that when I'm going downstream, I'm going 30 miles an hour. And this is my current and my motorboat speed working together here, because the current affects this. Then it said it took 30 minutes to go back upstream. So it took me 30 minutes to go the same 10 miles. So 10 miles in 30 minutes would be how many miles in 60 minutes? Well, here I times by 2. So when I was going upstream, I was only going 20 miles per hour. And that's when the current was working against me, right? So I'm having the current speed working against me. So I'm going to add the speed of the current and the speed of my motorboat together to find when I'm going downstream. Because when I'm going downstream, my motorboat speed and my current speed are working together. They're both pushing me down the stream. So my motorboat speed and my current speed are working together when I go downstream. And that, when I did downstream, I was going 30 miles an hour. So together, when they worked as partners, 30 miles an hour. Now when the current was working against me, meaning it was taking away from my motorboat speed, I only made it 20 miles an hour for my speed. So here's my two equations. I go ahead and I'm going to use elimination because look at it, set up really nice for it. My c's already cancel out. I have 2m equals 50 divided by 2, and I will find that my motorboat speed was 25 miles per hour. Is that what they asked for? And Excel Math will ask for the current speed also, so make sure you watch what they're asking for. My motorboat speed is 25 miles an hour. So I would say my boat speed was 25 miles per hour. And if they would have asked me for the current speed, I could plug that in and I would have gotten 5 miles per hour, right? If you have another way to do this, you do it in your head, you do it any other way, and you get the same answer as me, feel free to do that. I'm just showing you one way of how you can set it up algebraically.